All right. Bunch of stuff to do today. So let's get going. So the plan for today is to, again, we'll review the Intra-AS MPLS VPN. We would need to, because we would need to set up an Intra-AS MPLS VPN before we can connect it up. Then we'll take a look at Intra-AS MPLS VPN. Where does it come in to the picture and the different options. Option A, B, and C. Not only that, we'll also take a look at the same thing, MPLS VPN on iOS XR. If you get a chance, I will implement IPv6 on it. If you don't, we don't. My main plan is to finish the thing that we can. If we get a chance, we will. Review Intra-AS MPLS VPN. So what I'm going to do over here is, for people that are still joining in, generally they're over 50. Right now, I am seeing, how many am I seeing? About 30 right now. So there's some people still coming in. This is my topology for today. Okay, come on. Let's close this off. No, it's not closing. Second. Apps. It's not there. Anyways. All right, we'll just open it up anyways. Right click, open with photos. All right, this is the topology that we'll be taking a look at today. I want to set up an MPLS VPN. Over here. Where AS100 wants to connect up these two sites belonging to the same customer. We'll just use one customer today, Cust A. Site 1, Site 2, to each other. This is my PE router over here. This is my PE router. This being the route reflector, it's going to take the route. This is going to be my control plane. My data plane over here is going through this switch which connects the devices to each other. That is this guy. So my data plane is going to go this way. My control plane is getting forwarded through the RR like that. I also have router 13 over here. I'm not going to use that for right now. But the other thing is, let's say this is the US over here. I have another setup in Europe that I want to connect up. Same customer, but it has some sites over here. Over in Europe, it has 3 sites. Cust A. Let's call this site 3, site number 4, and site number 5. Actually, I can open this up in Paint and use that particular diagram then. Because I want to, for some reason, I want to show you what happens if I don't have this set up over here. So I'll get rid of this over here. I don't need this over here today. There you go. Camouflage it as much as I can. This is what I have over here. This is what I want to set up. Ooh. All right. This is what I want to set up with these being the 3 sites. Let's also put the sites over here for this customer. Site number 1, site number 2, site 3, site number 4, and I have site 5 over here. All good, guys? You guys understand this? The topology over here? So this is going to be acting as my route reflector over here. This is going to act as my PE router. This is going to act as my MPBGP route reflector. Same thing over here. This is the route reflector in Europe. These 3 are my PE sites in Europe. So this is the US, for example. And this over here is Europe. Good so far, guys? Is R4 a PE as well? It is not a PE because I purposely don't want it to be set up as a PE because there's certain things that I want to do with it. This guy later on is going to act as what is known as the autonomous system boundary router to connect the 2 autonomous systems to each other. So it will act as an ASBR. But for it to be in PE, it would need to connect to our customer site. So this router, router 8, will be an ASBR as well as a PE router. Understood, guys? But I purposely took out the site from R4 because I want you guys to see a specific thing, a specific characteristic of MPBGP. So with this in mind, let's go ahead and get started. Let's do our basic setup on the US service provider, AS100, so that site 1 and site 2 can talk to each other. This is my route reflector over here, which is R3. All right. So to start with, this will be a review for you guys because this is Intra-AS MPLS VPN. So we're doing the Intra-AS MPLS VPN in US. Okay. Remember the 5 steps that I've given you guys to set up Intra-AS MPLS VPN, IGP within the core, MPLS unicast routing, which is LDP, MPBGP within the core. Again, I'm going to do it based on that centralized model where the route reflector is the one that will set up a relationship with all the PE routers, and it's going to propagate the routes across. Then I have the PE configuration, and the last one is the CE configuration. So in the US, if you take a look at it, my route reflector over here is R3. These are the 3 devices that are inside my 3 other devices that are inside my AS. Let's go ahead and set up my IGP. Let me see if I have done that or not. Let me go to my devices, R1, show IP interface brief. Let me go ahead and load up this topology for you guys so you guys have it as well on your OneDrive. So as I go through it, if you want to take a look at it, you have access to it. You don't need to depend on me flipping between the diagrams. All right, so this is the one that I'm doing right now, and I will be doing these as well. So take a look at it. The one that I'm working on right now is number 4, option A. Okay, you can download it, have it open. So as I go through it, you guys can also see the same diagram. So it's there. Just refresh it. Got it? The link. I think if you, I don't know. Where do I go? Oh, there you go. Thanks, Ernie. All right, so coming back to my topology over here, let's check the interfaces. R1, R2, and R4 are all having direct connects to the RR, which is 13, 23, and 34. They're all directly connected to this common network 192.1.100.0, which is R1, R2, and R4 connected to each other. So I'm going to run IGP over here between R1, 2, 3, and 4 for reachability. 13 is that direct connect between me and the RR. 100 is a common network. 10 is my loopback, the one that I'm going to form the neighbor relationship based on. Let me see if I'm running a routing protocol. I'm not. So we'll start with that as our first step. IGP within the core. This is AS within the US, which is SP number 100. R1. Router OSPF. We'll do OSPF again, just so that you get the comfort level with it. Loopback 10. IP OSPF network. Point to point. Router OSPF 1, network 192.13.0, 100.0, and 10.0. So that's my IGP within the core. R1. Let's do R2 now. So my first task over here. We'll do this later on. Router 2 now. Show IP interface brief. 23.110.2. 23.110 is good enough. Loopback is 10. Copy it. This should set up R2, R3. This is the RR. This is the route reflector within my system. It has more networks. The loopback 10 is still there. I have 23. I have 13. And I have 34. And the 10 network is there already. So router 3 is done. Now the neighbors should come up between 1, 2, and 3. On the diagram, 100 is this common network earning. Connected to this switch. Got it? This is that segregation of data plane and control plane that I'm doing. So R3 is done. And I think the neighbors should be coming up on R3 as well. There you go, the two neighbors are there. So if I do show IP route OSPF, I should see 10.1 and 10.2. Perfect. And R4, the other router in there, again, it has 100, 34, and the 10.4 network. Again, we will check it. Show IP interface brief. Looks good. So I'll just copy this part over here. 34, 100, and 10. So it should also have any relationships come up with all the different devices. Three came up. 10.1 and 10.2 should also come up. There you go. Show IP route OSPF. I have full reachability. So my first task is done. Now the next thing, the next task over here in the same autonomous system is to set up MPLS LDP, the basic stuff. R1, MPLS LDP router ID, loopback 10. My two interfaces on R1 are E00, MPLS IP, and my other interface is E01, MPLS IP. Two interfaces in MPLS on R1. I don't set the interface towards my other side in MPLS. So copy this onto R1. Okay, this part is done. Let's do R2. R2 basically has the same interfaces. E00 is towards the RR. E01 is towards that common network in MPLS using that router ID as loopback 10. So again, when I do that, R1 and R2 should have an LDP neighbor relationship on that common network. And now R3, it has three interfaces in MPLS. It also has E02. You guys, if you have any questions as I'm doing this, please let me know. I'll be more than happy to answer the question for you guys. R3. Two neighbors should come up for MPLS. The third one is R4, which I haven't done yet. I'll do R4 now. R4 has two interfaces, the 34 network and the 100 network. Enable that as well. I should have the three neighbors over here. Does the interface on the RR need to be in MPLS? Yes and no. You don't need to have it, but I'm using it as a backup just in case something happens. So let's say this link. I can still, in that case, use this guy as a backup for my data traffic. All right. But if I have all the links up and running, I really don't need to. Because remember what I told you yesterday, I could do it without running MPLS for my control plane. Does that answer your question, Zahid? Not in the data path as a prominent with a predominant one, but no harm putting it as a backup, just in case the the data path is not there, rather than not having it at all, at least have it go through the RR. By default, it's going to use the 100 network, but just in case the 100 network is down, I do have the backup through the RR. That's why I ran MPLS on it. So that part is done. What does the RTR do? Start exchanging LDP. RTR meaning the router. The router starts exchanging LDP packets. As soon as you do MPLS IP on it, you enable LDP on the device. It will start assigning labels to every network in the route and exchanging the labels with the other neighbors. So it forms a neighbor relationship on that interface with the other neighbors and starts exchanging the labels with it, so that you can build the LFIB. Remember the whole thing that I had you built based on your table, the FIB, the LFIB, and all that? That's what gets started when you do MPLS IP on the endpoints. So second step is done. Now the third step. So now I need to set up my MPBGP on R1, router BGP 100, neighbor 10.3.3.3, remote AS is 100, neighbor 10.3.3.3, update source is loopback 10, address family VPN v4, neighbor 10.3.3, activate. On R1, the only MPBGP neighbor or BGP neighbor that I have is the R1. So this configuration will be the same on R1, R2, or R4 for that matter. Actually, I don't need it on R4 right now. So I'm going to skip R4 right now. I'm just going to do it on the PE routers right now. PE routers to the RR. So copy, go to R1. The reason I don't need it on R4 is it's not a PE router yet. Or it's not going to be a PE router. R2 will have the same config because it's also pointed to R3. All of the devices, all the PE routers will be pointed to the route reflector. So this is done. Now I will go ahead and configure my RR. Just like we did yesterday. It's just less number of routers over here. Neighbor 10 dot, or actually I'll do IBGP peer group. Neighbor IBGP, I'll say remote AS is 100. Neighbor IBGP update sources loopback 10. Address family VPN v4. Actually, sorry. I also need to set them up 10.1.1.1, part of the peer group called IBGP. Neighbor 10.2.2 peer group IBGP 10.1.1.1. Activate. Neighbor 10.2.2.2. Activate. Neighbor IBGP route reflector client. So both of them will have the route reflector client set up. So go to R3 and set it up. So I should have MPBGP come up. Should have two neighbors on R3, 10.1 and 10.2. So that's the third step taken care of. Now we go to the fourth step. That is your PE configuration. I only have one customer at this point. So for that one customer, step A, create the VRF. VRF definition, cast A, RD, let's say 100:1. Address family IPv4. Route target, both 100:1. And then we'll do B, assign the interface to the VRF. And that, in our case over here, it's E02. Why E02? I'm on R1. So who is my customer? My customer is R9. It's going to be 192.168.10. It's E02. This is what I need to do over here. VRF forwarding, cast A, IP address 192.168.10. Let's say .1. That takes care of that. Yesterday we didn't get a chance to run my ISIS as a protocol. Let's go do that real quick over here inside the VRF, because that's one thing that when I looked at the notes, that's one thing I had skipped. So PEC protocol is going to be ISIS, router ISIS, VRF cast A, that's how you do it. The net address, so let's say 49.0.0.0.11.11.11.11. That's the net address. IS type, I'll say level 2 only, because I wanted to basically talk to the other device as a part of another area. Redistribute BGP 100 into it, and router BGP 100 address family IPv4 VRF cast A, redistribute ISIS. So that would take care of my, oh, actually one more thing, I do need to do my interface in ISIS, E02, IP router ISIS. So that would be my configuration of ISIS on the PEC router. So that takes care of that. Let's go ahead and do it on R1. The RF cast A doesn't exist. Didn't we do it? Oh, I did in Notepad and copy it over here. Try to do it now. There you go. Now it looks okay. All good. So R1 is done. Let's do the other PE router, which is R2. This one will do BGP. Do simple BGP over here on R2. This was R1. This is R2 now. This remains the same. It's the same customer. The network address is 20.2, let's say. And we'll keep it simple over here. We'll just do BGP. Address family IPv4. When you're doing BGP only, can you guys see my screen? Neighbor 192.168.20.10. R10 remote AS is 100. All right, good. So this part is taken care of. This was simple. With BGP, it's a lot simpler. All you got to do is enable. Copy it. Go to R2. Create the VRF, assign the interface, and BGP. Interface is up. So that took care of my fourth step, which is PE configuration, and my last step. Which is my CE configuration. All right, on the CE router, which I have over here as R9 and R10. So let's do R9. It was running ISIS. So what I'll do is interface E0/0, IP address 192.168.10. I believe this was 10 on R1. Yeah, 10.1. I'll say 10.9. for router 9. Done. Interface loopback 0 will say is 10.9.9.9. And I will enable it in ISIS because it's running ISIS, router ISIS, net 49.0.0.1.0, let's say 9999, IS type, level 2, and I'm also going to run ISIS over. This should be good enough for R9. Let's check. Show IP interface brief. Show ISIS neighbor. That's my neighbor. It's a level 2 neighbor. If I go to router 1, show IP route VRF cust A. That's my 10.9 route. I have redistributed it, so show BGP VPN v4 unicast all. That's the 10.9 route over there. So everything's looking good. All right. It should also go to router 2 actually. Let's do that alias because I'm going to be using this command a lot. SVPN. Show BGP VPN v4 unicast all. So SVPN. 10.9 is on R2 as well. So that is also taken care of. Now the last router in this Intra-AS is this guy, router 2, or router 10, sorry. So let's do router 10 and we'll be done with it. Oops. Router 10, E0 is 20 is the network, and I'm going to be 10.20.10. I am not running ISIS. Loopback is, I'm going to put it as 10.10.10.10. And I am going to be running router BGP. Oh, what did I specify as the remote AS over here? Ooh, this is wrong. This should be, let's call this 65010. This was on R2. Fix this on R2. Router BGP 100, address family. Neighbor 192.168.20.10. Remote AS 100. Instead, it should be 20.10, 65010. So that's what I'm going to use as my AS number on 10. Network, I want to advertise 10.10.10.0. And my neighbor is 192.168.20.2. Remote AS is 100. So that should get my Intra-AS working between the two customer sites in the US. Good so far, guys? Let the neighbor come up. Once the neighbor comes up, show IP route BGP on 10. I see the 10.9 route. Let's ping it from 10.10. And I have reachability. All good, guys? So this sets up my Intra-AS MPLS VPN. We also knocked off ISIS as a protocol. This was my control path. My data path, I took this way. Why on 10, on router 1, the next hop for 10.10 should have been R2. We can verify that over here. If I go to router 1, show IP route VRF, cust A, to reach 10.10, my next hop is R2. And that's why, if you take a look at my path, I went from 2 to 1. I didn't go through 3. Everybody okay with this, guys? You guys understand the Intra-AS MPLS VPN? So it should have been a recap for most of it, except for I introduced ISIS over here as my PEC protocol as well. So that is also taken care of. All right. Now that I've done this, I will do the same type of setup where in Europe. The only thing is Europe has 3 sites, site 3, site 4, and site 5. So let's set up Europe as the Intra-AS as well. The good thing is because I have this copied or written in Notepad, I can just copy it and make changes as we go along. So copy this. There is 1. So this is going to be my Intra-AS MPLS VPN for a service provider 200. So when you guys go to the notes, you have demarcation points over here. Intra-AS MPLS in Europe SP 200 and SP 200. If you look at your diagram, has 7 as the RR, 5 and 6 and 8 as the PE routers. So first thing is IGP on R1. R1 over here is R5. So 5, 6, 7, and 8. 5, loop back 10, same thing. The network is not 13, it's 57. So if you look at R5, I have 57. I have the 200 network over here. So not this guy, I have 200. And the 10 network. 10 network is my loop back that I'm going to form my neighbor relationship based on. Again, I'm running OSPF over here. So R5 first. Show IP interface brief. 57, 205. And I should be able to ping it, or not ping it, sorry. Paste it. 57 and 200 and the 10 network. So that is the first one. The next one is R6, which is this guy over here. Should have 67, 200, and the 10 network. So this is 67, 200, and the 10 network. Copy. Go to R6, check the interfaces. 67, 200, and 10.6. Enable OSPF on it. The next one is my RR, which is in the middle. Has 57, 67, and 78. So these 3 networks over here, 57, 67, 78, and the 10 network. Copy it. Just bring this up. This is going to be my RR, 57, 67, 78. Enable them in OSPF. I should have 3 neighbors come up. 5 just came up. 6 should come up, and eventually 7 will come up. So let's just check 6. 2-way, so it should come up. It's just going through the election, the DR-BDR election process. So let it come up, and then I can check it. 01. Another 13 seconds before the DR comes up. And when it does, should have a neighbor relationship. There you go. And if I check my routing now, I should have 10.5 and 10.6. Good so far, guys? 10.5 and 10.6. Last one is 10.8 or router 8. This is 8 for me. And it has 78, the 200, and the 10 network. So this sets up my IGP within the second service provider quicker because I didn't have to do the config from scratch. I'm just making changes over here. Show IP route, OSPF, let it converge, and there you go, 10.5, 10.6, 10.7. Everything's good. So that took care of my first step. My second step was LDP. Again, the same thing, R5, the two interfaces, E00 and E01. E00 is towards the RR, E01 is towards the common network. So R5, MPLS. Then I go to R6, same two interfaces. Copy, R6. Should have an LDP come up with 5 over here. Done. 7 has 3 interfaces. Two neighbors came up. The third one is R8, which I'm going to now configure. 8 should have 3 neighbors or 2 neighbors come up. Oh no, 3, because on one interface we'll have 2. And this is here, 8. 3 neighbors, brilliant. So my second step is taken care of over here. MPBGP, R5 will point to 10.7 as my RR. The only thing is, this is going to be 200. Because I'm running AS200 in Europe. So we'll start with 5 again, point to 7. Remote AS is 200, looks good. And this guy again will look exactly like R5. This is R6. Router 200, 10.7, 10.7. Copy. R6. Paste it. And my route reflector now, which is R7. Router BGP 200. Remote AS is 200. The peers are 10.5, 10.6, and I will have a third one over here because R8 is my P router as well. Do you guys remember this? R8 does have a site over here. R4 did not, so I did not include that as my P router. This one does. And then I need to activate it for 5, 6, and for 8. This is my MPBGP on R7. Let's set that up. Two neighbors should come up, 5 and 6. Now the last one over here is R8, which is going to be identical to the other neighbors. R8, which was not there on the other side. So I need to do it, also pointing to 7. So that took care of my MPBGP step as well. Moving on to the PE step, R5, create the VRF. This is going to be 200, 200:1, because it's part of AS200. Assign the interface. So this interface over here is 192.168.50.5, and the peer will be 11. So this is going to be 50.5. PC, I'm not going to run this. I'm just going to run BGP instead. Address family IPv4. Neighbor 192.168.50.11. Remote AS will keep it as 650.11. Normal BGP setup. So R5 should be done. for the PE side. Everything looked good, no issues. Now going back, R6, the RF definition again 200, route target both 200, sign the address. This guy, if you look at your diagram, is 60.6. The PECE is BGP 60.12, I'll say. So this is 12, and that should do it for R6. I do have another one over here, which is R8, which is, again, I'm going to do BGP over here with site 5, which is router 14. So let's do it over here, copy this, and this is for R8 now. That's my new PE router, 200, 200 is good. This is 80, and this is 14, or I'm 80.8 on my side, and the peer is 80.14 in AS14. Let's go ahead and do 14 now, or not 14, 8, pointing to 14. So my PE routers are done. My next thing over here, once the PE routers are done, is the CE routers, site 3, 4, and 5, which is routers 11, 12, and 13. And again, the CE side, very similar, 11. So this is 50.11 because it's connecting to 5. I'm running BGP over here. So this is going to be 10.11. I'm not running ISIS. BGP 650.11. Oops. 650. Network 10.11.11.0. Mask neighbor 192.168.50.5. Remote AS is 200. So that should take care of R11. Let's see. My neighbor relationship should form. And if it forms, R5 should get the route. And it would propagate that route to R6. Then 11 is there, and it would propagate to the other P router, R8. 1011 is propagated to everyone. So that tells me this part is good. Now the next one is 12. Let's change this. I'll just copy this part over here. Similar. This is 60.12. I'm on router 12. This is 10.12.12.12. 12 and 60.6 is my neighbor, and 200. That is good. R12 should be done. Neighbor should come up. And when it does, I should see a BGP route for 10.11. There you go. I should be able to trace to it. Source 10.12, 10.12, 10.12. So I'm going from my router, which is 12 to 6 to 5 to 11. So those two are communicating to each other. The last one is 14. That is this guy over here. Let's put this config over here. And that should finish out my intra-AS within AS200. This is 80.14. Advertising 14, 14, 14, 14, 84.6, copy, set it up, should IP route BGP. It should have 10, 11, and 10, 12 propagate. There you go. Ping 10, 11, source 10, 14, and 10, 12. Good so far, guys? Everybody okay with this? Nothing new over here, except for that I ran ISIS. Right now, what I have, end result, is these two guys are communicating to each other. These three guys are communicating to each other. Within Europe, they're communicating to each other. Within US, site 1 and 2 are communicating to each other. Good so far? Everybody okay with this? Now the thing is, I want US and Europe to be able to talk to each other. I want site 1, 2, 3, 4, and 5 to have connectivity to each other. How do I set it up? That's what the options are for. This is known as, when I do that, when I allow my sites to connect between two different autonomous systems from 100 to 200, this type of MPLS VPN is called an Intra-AS MPLS VPN. So far, we have been doing what is known as Intra-AS MPLS VPN. Everybody good with this? You guys, any questions in terms of what I've done so far? And it would not be a bad idea to save this config file. A lot of good work in there. Save as day 3. Understood? Now, to connect the Intra-AS MPLS VPN, there are 3 main options. Option A is called back to back VRF on ASBR. I'll explain what that is in a second. Second option is option B, MP eBGP between the ASBRs. Option C, MP eBGP between the RRs. So within the same region is intra. Intra means within. Inter is between. So what I'm doing right now is inter. Now what I'm going to do is inter. Good so far? So let's take a look at the first option. What is the first option over here? Option A. In option A, what I'm going to be doing is use the same mechanism that I have been using, in the sense that I'll get all the routes into this router, into the VRF for class A. I'm going to use this link to the other border router or the edge router on the other autonomous system as if he is a CE router. I'm going to act as a PE router and make him act as the CE router, as if he's a CE router running BGP as a protocol. So whatever routes I get into my VRF, I'm going to send those routes to him, so he will get the routes as BGP routes. From the perspective of AS100, I am connected to R8, and R8 is a CE router for me. So I'm going to send all the routes that are inside VRF cast A to R8. R8 will act as if it's a, what type of router? It is a CE router. So he receives the route. Again, in the VRF, on R8, I'm going to configure this interface to be part of the VRF cast A. R8 is going to treat R4 as a CE router. So you're going to have these two guys talk to each other as if for him, he's the PE and this guy is the CE. For him, this is the PE, this guy is the CE. So whatever route I send to him, I'm going to receive it in the VRF because I'm going to act as a PE router, receive them, and propagate to everyone else. You understand that? So from the perspective of the configuration, it looks exactly like as if you're doing what? A normal PEC protocol. But the problem with this type of setup is scalability. Let's say this is customer A, which has 5 sites, 2 and 3. What if I have customer B, customer C, customer D, customer E that have a similar type of requirement? I have a physical interface over here. So what I would need to do is create what? Sub-interfaces and assign the sub-interfaces, each sub-interface to a different VRF so that whatever routes that I send in across this link, connecting these two routers to each other, they will be put into different sub-interfaces. So for example, this will be E0/0 or E0/ what is it? Should be 0, 1, 2, and 3. This is 3.2, E0/3.3, E0/3.4. So it's the same physical interface, but multiple logical interfaces. So for every VRF that I need to go from one site to the other, one AS to the other, I would need to create sub-interfaces. So although it's easy to configure, the problem with this type of setup is scalability. Option A, and by the way, the edge router in an autonomous system that talks to the other edge router is known as an ASBR. So from the perspective of terminology, this guy over here is known as an ASBR. This is the actual ASBR, not the one that you have in OSPF. That is not an ASBR. That's what OSPF calls it, the redistributing router. But this one actually is the ASBR, autonomous system boundary router. This is the boundary router for my autonomous system. Understood? So option A, the ASBRs treat each other as if they were normal CE routers. They receive the route from the other ASBR, treating it as a customer edge router for the VRF. It will propagate the route to the other PE routers within the domain or within the AS. The advantage of this setup is that it is simple to configure. The disadvantage is what? That it is not scalable. So if you have a lot of customers going across, for every customer, I would need to have a separate logical link between the two ASBRs. Everybody okay with this? You guys understand that? I'll show you the setup, understand where or when would I want to use it. So if I have a one-off type of situation where I don't have too many customers spanning from the US to the European side of the ISP, 2 or 3 customers, it's okay to do it, because I don't want to send my MPBGP routes to the other side. Understood, guys? Option A. So how do I configure it? Now, the first thing that I need to do over here, and that's what I wanted you guys to see, that's why I didn't set up the R13 over here, is right now the customer ACE routes, who has them? R9 send it to R1, R1 send it to the RR send it to R2, which send it over here. The ASBR is not involved in those routes. Why? It does not have a PE router. It is not a PE router that connects to another customer. So I do need to get involved. I need to get R4 involved, that it will also receive the routes from the RR. Which routes? The customer routes A and B, and put it into what? Into the VRF. VRF for what? VRF for cast A, because cast A VRF is the one that I'm going to receive the routes and propagate the routes to him. Okay? So how do I go about doing it? Let's take a look. Configuration. Step 1, configure the ASBR in AS100 to receive the routes from the other PE routers from the RR. How do I do it? On R4, router BGP 100 neighbor 10.3.3.3, which is my route reflector, AS100 neighbor 10.3.3.3, update source loopback 10, neighbor, address family VPN v4, neighbor 10.3.3.3, activate. Okay, and on R3, I have already done, if you guys remember, I already have that peer group created. So I'm just needing to add 10.4 to the peer group and activate it under the VPN v4 family. So on R3, router BGP 100, neighbor 10.4, peer group, IBGP, address family VPN v4, neighbor 10.4.4, activate. R3, let's finish up R3 over here, and then we'll go to R4, activate it. Now, question for you guys. My neighbor is up. Should I see my BGP routes over here? Why not, Hari? Why not? No RT, absolutely, because I don't have a VRF yet. I do need to create a VRF in this case. Why do I need to create a VRF in this case? No, not redistributed. See, I have gotten the routes. It would come in as a BGP route, an MPBGP route. Remember that default route target filter says, okay, I've received 10.1 or 10.9 and 10.10, but I don't have any VRF that requires them. So because I don't have any VRF created at this point over here, I'm going to discard the routes. But I do need to create a route. No BGP default route target filter, absolutely. But I do need to do what? I do need to create a VRF over here. As I said, I'm going to treat the R8 as if it's a CE router. So I do need to create a VRF on this interface, E03, towards R8. So what I'm going to do over here is, once this first step is done, let's do this first. Once this step is done, step 2, configure R4 to treat R8 as a CE router. So how would I do that on R4? VRF definition, cust A, RD, same thing that I would have done on a normal PE router. Route target, both 100:1. Okay. Go to the interface. This interface between 4 and 8 is E03. IP address. The address is 48.4. If you look at the diagram, you'll see that. And run BGP over here. Address family. IPv4 VRF cust A. And my neighbor is 48.8 remote ASS 200. You guys understand that? Now that I've created the VRF, now I'll see the routes. So over here, at this point, I don't see the routes. Although I'm getting it, I'm discarding it. But now once I create the VRF, assign it to the interface, and then run BGP over. So now R4 is treating R8 as a CE router. So whatever routes it gets into this VRF or E03, it is going to send it to R8 when it's configured. And R8, I'll do the same thing. Configure R8 to treat R4 as a CE router. So on R8, I don't need to do this part. Why not? I wanted to do this specifically to show you that because R8 is already acting as what? As a PE router, it has already defined the VRF. So this one did not have a PE configuration, so it did not have the VRF created. For R8, I have already done that. So the VRF is created. I do need to assign this interface to be part of that VRF and run BGP with him, a normal BGP at this point. All right. So coming over here, I don't need this, but this part I do need. 48.8. This is router BGP 200. And my neighbor is 48.4 in AS 100. So whatever routes I get, I'll send it to him as if he is a customer edge router. So that I'll do on R8 towards R4. By the way, on R4 now, that MPBGP command that I have, I would show the routes. Not only 9 and 10, I also see 11, 12, and 14. There are two, basically you created two distinct, what do you call it, LSPs. So my label switch paths are different. So the names is irrelevant. Name is always irrelevant. Even within my own Intra-AS, I could have technically called this cust A, and this one could have called this customer A. Customer names or VRF names are locally significant. What allows the routes to go from this VRF to that VRF is your RTs. As long as those match, it's fine. Now you might say, well, this RT over here is 200:1. Yeah, you're right. But once it gets over here and he sends the routes here, it is a normal IPv4 route. So it does not have any RT going from R8 to R4. It's a clean IPv4 route. When he receives it, incoming, it will set the RT on. It's just treating him as a customer who's sending a non-RT route. He's going to set the RT as 100:1, and he's going to send it to them as 100:1. You understand that? So they don't even need to change their RT values because I have two distinct what? Domains running right now. So this is entirely two different domains where they're treating each other as what? Customers. Got it, Zahid? So the name's irrelevant. Even my LSP now, my label switch path is going to be from where? My LSP will be that all the way over here. It'll be POP because this link is treated as what? A non-MPLS link, non-BGP link. So not non-BGP, non-MPLS link. All right. So if you do a trace over here on R9, 10.11.11.11, source 10.9.9.9. See in the middle from 4 to 8, it is a IP packet. That's the link that is not containing the LSP. So the LSP is broken. You have two separate LSPs in there. Understood? Just like when you go to a customer, all your labeling is gone. Labeling is only within the service provider cloud. But these two service providers are not treating each other as one. They're treating it as two different ones. Good so far, guys? Everybody okay with this? Any questions on this? It's a very simple setup comparatively speaking because I'm treating each other as a customer. So it'd be basically the same type of configuration commands. From in your mind, you just treat that other ASBR as just a CE router and configure it. So you become the PE router. Now, my question to you guys is this something that you would want to do on a regular basis? It becomes tough to do if you have too many customers going between the two sites. Have I seen any of my customers do it? No, personally, I haven't. But I've had people that have come into my class. I had a group of people from a telephone company in Germany come up, where in Europe there's different telcos in different countries, in these small countries over there. And they basically had done this for a specific ISP where they had a very small requirement where one or two customers that were connecting from one side to the other. So over there, they had done this. So that's the only time I've heard about some ISPs using A, because it's very limited in terms of the configuration. B and C are the most common. And C, if you have a volume type of setup, is the preferred one. And we'll talk about that. Good so far, guys? A okay? All right, so this part is taken care of. The drawback we've seen. So what's the solution to that? The first solution is, rather than doing this for each and every, what do you call it? Customer as a separate VRF over here, I will set up an MP eBGP relationship between the two devices. Scalability and manageability becomes an issue if you have numbers. If you don't have numbers, then it's irrelevant. And that was exactly what they told me, was they had 2 or 3, I think 2 or maximum 3 customers between these 2 service providers. So that's where they used it. Personally, I haven't. So let's go to number 5 now. Number 5, again, if you guys remember, we're not doing this one. All right, so it's still the same setup that I have over here. These are my 2 ABRs. I am going to use an MP-eBGP neighbor relationship. These 2 customers, let's say it's AT&T in the US and AT&T having a presence in Europe as well. But they're 2 different service provider numbers, part of the 2 different domains. So what they want to do is they want their customers to have the flexibility of going from one side to the other. So what they want to do is they want to set up what? A complete MP-eBGP between what? R4 and R8. What did I call R4 and R8? What was the name that I gave them? The ASVR, the 2 routers that are connecting the 2 autonomous systems to each other. So in this case, I'm going to set up MP-eBGP between what? R4 and R8. Good so far? But before we do that, let me get rid of the config that I had between 4 and 8 so that they do not have that configuration over here. So for R4, first thing that I'll do, no VRF definition state. So that took care of that. Show run section router BGP. 10.3 I still need, so I'll keep it, but as you guys can see, 192.1.48 is gone. I don't have any VRFs, so blank router in terms of VRFs. R8, I cannot do that. I'll just get rid of what? My neighbor. 48.4. So right now, you take a look at R1 now, it is only containing 10.9 and 10.10. If I take a look at R10, it should have the 3 from its domain, which is not 10, sorry, 11. Should I be route BGP? It would have 10, 11 is itself, 12 and 14. So now I've segregated it. Now I'm going to do option B. What is option B now? Option B, the ASBRs configure a MP eBGP neighbor relationship between each other. This provides a single control plane from one edge to another. So basically all the routes will be propagated across from one side to the other. This will also require a full label switched path from one edge to another. What I mean by that is because now it becomes one domain. Before, in the previous example, when I showed it to you, you saw that on this link, the packet was what? An IP packet, because this link was an IP packet. When I combine them into a single domain, every leg needs to be a label path. So R11 all the way to 9 or 10 or 12 to 9 and 10 and vice versa, or to 14, everything should be labeled. All right? So you have to have labeling all the way across. So this link that was not running MPLS before, or labeling, I shouldn't say MPLS, which was not running what? Labeling before, I need to run labeling over here. On which link? The link between R4 and R8. All right? How do I do this now? So now I need to get all the routes on R4 so that I can propagate those routes. I would have learned them through what? MP, IBGP. This guy will send it to RR. RR sends it to what? R4. R4 receives them through MP, IBGP, and then uses MP, EBGP to send it to the other guy. He gets it, he's going to forward it to the RR over here, which will forward the packet to the appropriate devices. Understood? So the first thing that I need, which I already have in this site, is a MP-BGP name relationship with what? My RR. I have it over here. I need the same thing over here and here. I have that. I also need it over here. Assuming I had not done option A, I would need to set up this part over here on R4. What is that part? The MP-BGP name relationship. Good. So let's do that over here. I have it, but I'll put it into your commands. So first step, configure an AMP IBGP neighbor relationship between the RR and the PE router. Sorry, not the PE router, ASBR. So although I've done it, I'll do it for you guys again, R4. Actually, I just copy pasted. I had done it over here. This thing. I don't need to do it again over here, but just remember that you would need to do this if you're doing it from scratch. My stuff is done. Now this other thing becomes an issue. Do you guys remember in the previous example, I did not receive the routes. Although I received the routes, I have a neighbor relationship with the RR. I receive the routes and discard the routes. Because I do not have what? No VRF. So again, I'm not going to have a VRF over here. It's an ASBR generally. So although it has a PE router over here set up because of the VRF, this is not common. Generally, the ASBR is a router that's set aside just for connecting the two domains to each other. So what you see on AS100, where the router, the ASBR, does not have a VRF on it, is common. So what do I need to do to get the routes onto R4 without creating the VRF? This is where that no BGP, default route target filter, becomes important in the sense it's essential to do. Otherwise, I would not receive the routes. If I go to router 4, right now I don't have, I guess I don't have that created over here. Show VPN v4, sorry, BGP VPN v4, unicast all. I don't have any routes over here. Why? I do have a neighbor relationship. I don't have a neighbor relationship, or do I? Oh yeah, I do. Summary. See, my neighbor relationship has been up for what, 20 minutes now. But I'm not seeing those VPN v4 routes again because the route target filter. So the first thing that I need to make sure is I do get what? The routes in there. I need to have the 10, 9, 10 routes over here so I can propagate to the other side. So the first task over here, this is what I want to add over here. Note, make sure the ASBR receives and keeps the VPN v4 routes. And how did I do that? On R4, no BGP, default route target filter. Everybody okay with this step, the first one? Good. The next thing that I need to do over here is set up the MP BGP relationship between what? Between your ASBRs. How do I do that? Configure a MP eBGP neighbor relationship between the ASBRs. So by default, the ASBR discards the VPN v4 routes without the no BGP. Absolutely, because it generally would not have a VRF on it. So this is where that command almost becomes essential. Now I'll do the MP BGP relationship over here. How do I do it? On R4, I need to configure the interface first. I don't have it. Interface E0/3, 192.1.48.4. Because when I blew the VRF away, it went away. Router BGP 100, neighbor. 192.48.8, remote AS is 200. And I want to do what? Address family, VPN v4, neighbor 48.8, activate. Good so far, guys? Okay. And on R8, the interface is 48.8. Router BGP is 200. This is 4. Remote AS is 100. This guy is 4. One more thing that you need to do over here. This is eBGP. Don't forget that. So whatever routes, MP eBGP routes that I receive over here, and I send it towards my RR. The next hop for 1011 will be what? Normal eBGP to iBGP. When this guy sends a route to him, what's his next hop? For 1011 on R4, what's the next hop for R4? Everybody agree with that? R4 sends it to 3. Does R4 change the next hop to itself by default? from E to I. This is EBGP. This is IBGP. It doesn't. So he will have a next hop of 192.1.48.8, which is not reachable. You understand that? So what I would need to do over here to make it work is I need to also specify that neighbor 10.3.3.3 next hop self. And same thing where this guy for 10.7, because my, what do you call it? My route reflector in AS200 is 7. So let's do 4 first. Done. And let's do 8. Done. Let the neighbors come up. Make sure my config on E03 is proper. Ooh, I got the VRF still on this one. No VRF forwarding. Last day. There you go. The neighbor is up. Show MP, show BGP, VPN v4, unicast all. I'm receiving the routes from the other side now. On R4, yes, I do. I didn't delete it. I didn't get rid of the VRF completely. I just took it off the interface. I don't need it on E03. That's the interface between R4 and R8. What I did was I took it off of this interface. I had it because of the previous config, option A. So now let's take a look at the BGP routes. I'll go to 4, show BGP VPN v4 unicast all, 10.9, 10.10 local, 10.11, 10.12, 10.14 on R4 is received from 48.4. Everything looks good so far. On 8, do show BGP VPN v4 unicast all. I am not receiving the routes from 10.9 and 10.10. How's that? That should come through. Ten one, 10.2 is there. Oh yeah. Why don't I have it on the ASBR over here? For 10.9 and 10.10. You guys tell me. I do have the VRF. I have a VRF over here. But the problem over here is different. The VRF over here right now has an import RT of what? 200:1, which gets all these routes in, right? The RT does not change over here. The RT of all these routes is 100:1. Now there's 2 different ways of doing it. One general, normal real life scenario is you would generally not have what? As I've been telling you, You would not have a PE router or a VRF hanging off the ASVR. Its function is just to connect the two devices to each other. So normally you would use the no BGP default route target filter command, but in this case, because I do have a PE over here, I do need to get these routes. One of the ways I can do it is in my VRF for cast A. I can say import RT of 100:1, which I would need to do anyways to get the route from 9 and 10 into 14. So either way is fine, but I'll do it based on the other command because that's something that you would need to do anyways in real life. So again, that no BGP default route target filter that I did over here, I would also do on what? On R8. Otherwise, it would not receive the route. So if I do that command over here right now, R8 would start receiving those routes. All right. So I have these routes. Who does R4 or R8 send those routes to? So now I have exchanged the routes between what? These two entities. This MPBGP has worked. I have gotten the routes across. Who do they send it to? Who's their only internal BGP neighbor? For R4, it's this. For R8, it's this. So let's see if these guys are getting it. So if I go to 3, show BGP, VPN, v4, unicast all. Okay, I'm getting it. And because of the next stop self, I'm getting it from 10.4, which is good. And R7. I'm getting it as well from 10.8. So everything is fine at this point. Now, what's the next place that I want these routes to be propagated to? Right? Do they have it? Or for that matter, this guy. Let's check the VRFs. Or for that matter, the MPBGP table. Let's go to 1. Show BGP, VPN, v4, unicast all. I'm not seeing 10, 11, 10, 12, 10, 13. Why not? Again, the same problem. The import RT. I don't have the import RT for the other guys. They have exported as 200:1. So what I need to do in my VRFs, I need to go into my address family, IPv4, import, route target, import 200:1. Once I do that, I will get the route not only over here, see this, but also in my VRF. You get my point? Because now it's an end-to-end MPBGP relationship, so my route targets need to be maintained. Next step, once this is done, and that's actually my last step over here, configure the PE routers such that the VRFs import the RT from the other AS. So I've done R1. What did I do on R1? Set VRF definition, cast A, address family, IPv4, route target, import 200:1. Somebody asked me a question yesterday, why do I have the ability to import multiple RTs? This is another example of that. I don't have a choice, I have to do it over here. Or that, or export differently over there. Done this over here. Show IP route, VRF, cast A, 9, 10, 11, 12, 14. Now what do I do on the other side? On the other P routers, R5, R6, and R8. Same thing, I'm going to be importing what? 100:1. R5 before and after. Show IP route, VRF, cast A. I only have 11, 12, and 14. I will change my VRF. And now see 9, 10, 11, 12, and 14. And do the same thing on what? 6 and 8. Six and 8. No. Then it would have been okay. But again, Ernie, don't just look at it from a lab perspective, also look at it from a real life perspective. Generally on your P, on your ASBR, the P would not be there. But to answer your direct question in terms of if I had done it, I would not need to do the no BGP default route target filter. Because then the route would have been a valid route. Because I have an import RT that matches. Once inside, it is inside your VPN v4 table, whether I did it based on no BGP default route target filter or the import RT, I would be able to propagate it to my RR. And now all my edge routers have reachability. So I can go from, I'm on 9, I'm going to 10, 11. Reachability is there. And even on this one, I'm doing labeling now because of the MPBGP labeling. So 11 was reached, 12 should be reached across, and 14 should be reached. Local, we already established that I can reach the local one. Good, everybody? Now, I know there's a bunch of different things that I've gone through. That's what the video is for. And the other thing that if you correlate the video with my notes, you need to practice it, but if you practice it, this is it, man. When you look at it once, when you look at it initially, you see a lot of stuff over there, and you say, where do I start, or how do you do it? You look at my steps. I try to make it as simple as possible. Breaking it down one step at a time. What are you doing? What's the consequence of a particular command? But you do need to practice it. If you practice it, it's not that tough. One step at a time. No, I didn't. When you run MPBGP and you exchange the VPN v4 route, it does MPLS BGP forwarding over there. So the VPN v4 label is exchanged on that. Yeah, you do need to do it yourself. It's another thing me doing it, and another thing you guys doing it yourself. Good. That takes care of what? Option B. So if you take a look at this, we're right over here now. Option C. First things first, let's get rid of B so we can work on option C. So 4 The main thing is I need to router BGP 100, no neighbor. That should take care of most of it. All right. Router. That should get rid of it. What else did I do over there? That is detrimental. Next up, so that's it. Yeah, this is fine. I don't have time, man. Another hour will be done. Take my class, hurry. I do all that stuff in my SV class. I've covered so much in, what do you call it? In these 12 hours, believe me, this is tons of stuff. It's covered a big portion of your SV. Kenny, you here today? I don't know. I don't see the list. Are you? Yeah, there you go. We've done this, right? I don't know why you're here because you've done this already. Oh, by the way, this is a good point that that you brought it up in terms of the stuff that I'm covering. I don't know if you guys know about my annual package or not. Like, this is a good time to just bring it up because I have a really nice offer for Christmas for you guys for RouterGods only. I have an annual package in which I cover 5 tracks. I cover the route switch. I cover security. I do the service provider. I do DC and CCD. These are the 5 expert level tracks that I teach. What you've seen over the last 2 days is exactly the same format that I cover it on. The only difference is it's on the weekends. Okay? The whole thing, I generally do it, I give up a package price of $3,000. Okay, good. Yeah, it's always good. So you pay a single fee of $3,000 that covers all the 5 tracks, and you have unlimited retakes. You get videos for all the tracks, just the same way that I've been doing this class, along with what do you call it? The notes and the diagrams. Okay. So this is normally the package that I run, and you can do unlimited retakes for the period of a year. Kenny is in it. Probably other people over there here as well, but I know I saw Kenny's name when I was going through the list initially. He's been, how many classes have you taken, Kenny, so far? I know you've taken route switch and SP, right? Or DC as well. So these classes are on the weekend. Any weekend that you come in, you'll have about 3 classes happening. But the offer that I have for you guys right now is I'll extend this offer for 2 years, because some people have talked to me and said, hey, listen, I cannot take so much time out. So if you guys want to do it and you're part of RouterGods, I will give you guys the same package for 2 years. So if you sign up now, you'll have the package for till end of 2020. But when you send the email, in the subject, just specify RouterGods. So the same thing, so you can space out your study plan for 2 years and sit any of those classes. And even if you can't sit, just let me know at the start of the class that you want to be part of the class. I'll put it on the distribution list for that particular class. So as soon as the class is done, the next day I'll send you the video, the notes, and diagrams for all the classes. And all the classes that I teach, I take it from the CCNP level, and then I slowly build it up to the IE level for every topic. So if you guys are interested in it, send me an email. This is the best time to sign up for it because this is just for RouterGods. I don't make it available globally. It's an annual package normally. But for RouterGods right now, I'm going to offer it for 2 years. Same package, same everything, but you need to sign up before the 31st of December. Yeah, Miguel, oh, you're there as well. Good, yeah. You've been attending as well, right? Or getting the videos. Good. The email address that you want to send it to is khawarb@khawarb.com. Well, there's different there's a class that I start at 8 a.m. your time as well, right? The second slot. There are 3 slots, right? So the other ones you can get the video for, the other one you can get that. The good thing is on Saturday, so you always have the chance to do it. So if you guys are interested, let me know. And also, if you guys don't mind, post it in RouterGods as well. I'll talk to Katie as well to let her know about it. But you also on your own side, let people know that you can do that. Does RS become less relevant with SDN and SP more relevant with the cloud? Even when you go into SDN, there's some stuff that you don't need to worry about in terms of route switch. But at the end of the day, let's say you want to do anything with ACI, you need to exit out to your layer 3 network. You need to know what your VLANs are. So that information, that knowledge is still very relevant. You would not be able to do an L3 out if you don't have an understanding of, what do you call it? About EIGRP or OSPF. Like when you go and configure, even within ACI, when you configure your L3 out, you need to configure your OSPF area type, whether it's a stub area, not so stubby area. You need to configure OSPF characteristics. So all those things are still relevant. Yeah, it becomes less in the sense there's a lot more to it, but those core technologies never go away. You understand where I'm coming from, Bill? So I don't think they're going away anytime soon. That knowledge is always going to help you, always. Yeah, that's what I think. Yes, even with I've been teaching ACI for about 2 years, 2.5 years now. But if you don't have your route switch in place, it really, really hinders your growth, even in ACI. Peter, this is a good time, man. I'm telling you, 2 years you have access to the stuff, so something that you might want to look for. All right, so last one now, which is this guy over here. Option C. What is that? And what's the drawback of this setup over here? All right, good. Good, man. So the problem over here is the load on this device. What do I mean by load? Remember that thing that I talked about, control plane versus data plane? This router, R4, needs to have all VPN v4 routes. So a lot of memory. Plus, it's also the data path. This is the actual data path that is taken from AS 100 to 200. So router 4 is being used for control as well as for data. He needs to maintain, let's say, these routes from the different customers is, let's say, 10,000 routes. So he needs to process those 10,000 routes in memory over here, plus also is responsible for passing the data. Okay? One of the things that you can do over here, and that's what option C is, you can set up an MP-EBGP relationship between what? The RR, where the actual packet for the exchange still will go through what? Here, but he is now passing it as data. He's not processing it. He does not need to keep, let's say there were 10,000 routes over here for the customers. They're over here. They're over here. They get exchanged through here. But this guy does not know about those 10,000 routes. He's just a data plane device. So there's no MPBGP over here on the ASBR. ASBR is only responsible for what? Data. So the route exchange, the control plane, is segregated from where? From your ASBR, where the control plane is on the RR, and your data plane is where? On the ASBR. Everybody okay with that? And that is option C. Both option B and option C. Use MP-EBGP. Okay? Both option B and option C use MP-EBGP. The difference is option B is between what? ASBR to ASBR, whereas option C is between RR to RR. Absolutely. And not only that, you're segregating the load. So this guy, you can have more memory. This guy, you can focus on speed. Absolutely. Absolutely. And you should do that. You should do that because that gives you redundancy as well. Here, to do that would be too complicated, but normally in real life, you would have an RR cluster in both domains and have a setup where you have a full mesh neighbor relationship between the two RRs. That's a normal service provider type of setup. You won't have the single point of failures over there. Here with option C, we shouldn't be running MPLS between RR and RR clients, meaning data path you're talking about. Okay, we'll talk about the data path in a second. Let's do this first, and I'll explain the two different options within option C as well. We'll do the simple one first, and then we'll do the other one. So how do I do this? In order to set up a MP-EBGP neighbor relationship between R3 and R7, first of all, I need to have the IP address for R7. Right now, there's no BGP running to exchange any routes from this domain to that domain. Normal IP reachability so that I can establish what? An MP-EBGP neighbor relationship needs to be there. I don't have that right now. So the first thing that I need to do is I need to take the 10.3 route, send it through BGP into what? Into R8, and from R8 it will go to R7 to everyone basically. So I need to leak out my RR's loopback address to AS200 so he can form a neighbor relationship, and I need to leak out 10.7 to whom? To this guy, so he can establish a neighbor relationship to the other side. You guys understand what I'm trying to get to over here? So I need to set up the base configuration over here. How do I do that? Let's take a look. So option C. I'll copy this and try to make changes. The RRs configure an MP-EBGP neighbor relationship between each other. The ASBR is used for data plane traffic only. You do need to send the loopback reachability addresses to the other AS via the ASBR. This is done by redistributing the IGP into BGP with route filtering. I'm not going to send all the routes. I'm just going to send the specific route that I need. For example, 10.3 will go to AS200, 10.7 will come into AS100. You do need to maintain LSPs end-to-end. What is an LSP? Label switch path from end-to-end. When I exchange labels, guys, what does LDP use to exchange labels? What type of labels does LDP exchange? LDP exchanges labels for IGP. So when I have two routers communicating to each other, R4 and R8, R4 is going to send a route over here, 10.3.3.0 to whom? R8, and he's going to send what? 10.7 to him. Even if I wanted to, and I run MPLS IP over here, LDP would not allow me to generate a label for 10.3 or 10.7 because these routes are what? BGP routes. But I need labeling to be done on this device for 10.3 and 10.7. So when I send my normal IPv4 route through BGP, which is 10.3, I need to tell BGP, hey, listen, whenever you send this route, please generate a label for it. So BGP is responsible for generating its own labels for IPv4 routes. So any routes that are exchanged, because I need to have an end-to-end LSP, BGP needs to send a label for any routes that it exchanges because LDP will not do any labels for BGP routes. So between the R4 and R8, I need to send any route that I send, which is an IPv4 route, I need to include a label for it as well. Otherwise, my LSP will be broken. So I'll do that. I'll explain that as we go through it. This is a model or option that segregates the data plane from the control plane. Everybody okay with this? So what's the first thing that I need to do? First thing I would do over here exchange the RR loopback routes with each other. Okay, that's my first task. So the way I will do it on R4, you take a look at R4, show IP route, OSPF. I have learned 10.3 through what? Through OSPF. You guys agree? Right? So what I want to do over here is I need to exchange the loopback by redistributing OSPF into what? Into BGP. Running BGP between R4 and R8. Actually, I would do this step first. Configure the BGP relationship first. Configure not an MP BGP relationship. Configure an eBGP neighbor relationship between the ASBRs. Normal one. I don't need this anymore because I'm not receiving any MP BGP routes. My neighbor is going to be 192.1.48.8. Remote AS is 200. And because I told you about the labeling, any route that I send, along with that, I'll send a label for it. And on R8, I would just flip it around. 200 to 4 and 100. That's my first task. Set my neighbor relationship. Normal BGP neighbor relationship. This is exchanging. This is set up so that I can exchange the loopback reachability. My end result, after everything is done with the redistribution and everything, R3 should see 10.7. So it can establish a relationship with each other. So that's the first task. Second task, exchange the RR loopback routes with each other. This again on R4, I'm going to create an ACL. 1, permit 10.3.3.0. Call it inside a route map. We'll call it O to B, OSPF to BGP. Match the IP address 1. Router BGP 100. Redistribute OSPF 1 into BGP, right? With a route map O to B. All right. So that's my first task, is to redistribute the routes between the two devices. And on R8, I'm going to say I want to redistribute 10.7. You guys understand why I'm redistributing 10.7 or 10.3? So that R3 and R7 have reachability, so they can set up an MP eBGP neighbor relationship. So R4, done. show IP BGP, I should see 10.3 in my BGP table. And I'll do the same thing over here on 8. So now I should see 10.3 and 10.7 over here. I should see 10.3 and 10.7, not here, sorry, over here. So the routes are exchanged. Now I'm not done though. Although router 4 has a route in the routing table as a BGP route, 10.7 now, he will not propagate the route to R3 because he's not running BGP with R3. What's he running with R3? He's running OSPF. Connected. These are not connected routes. R3 is not connected to R4. R3 is, or 10.3 is, this guy is loop back. Right? That's the one that I want to send from my OSPF domain into BGP and vice versa. So now, although R4 and R8 have it, I need to take those BGP routes and send them into my IGP. So eventually the entire domain has it. So I not only do that, I will also need to do what? Access cache list 2, permit 10.7, because this is a route that I will receive from BGP. Route map, I'll call it B20 BGP to OSPF. Match IP address 2, router OSPF 1, redistribute BGP 100 subnets. So I'll take that 10.7 route and redistribute it into OSPF. Now BGP routes will also have labels because of the send label. So when I send the 10.3 route or the 10.7 route, you will have a label over there assigned to it. So again, once this guy gets it, I need to forward it to R3. That's what this guy is doing. So right now, R3 does not have 10.7 because I have not redistributed a BGP route into OSPF, and that's what this is doing. 10.7, B2O. Oops. I want to make it more specific over here. Route dash map B2O. Otherwise, it's going to redistribute all BGP routes. Maybe I don't want that. So once I do this, R3 should now have 10.7 in the routing table. So now R3 is ready to establish an MP-eBGP relationship between the RRs. And same thing I need to do where? This guy. The only difference is this guy over here will be 10.3 because 10.3 is the one that I want to redistribute from BGP to OSPF. This is 200. This is all good. BGP 200 with the route map. So this I'm going to do on 8. And by doing this, I should have propagated 10.3 over here. Do you guys see the step? The purpose of this step over here. Step 2. So I have reachability now from R3 to R7. That's what I'm establishing. Basic reachability with labels. The label part is the send label that I set when I configured R4 to R8. Now I'm ready to do what? This is step number 3 now. Configure an MP-BGP relationship between the ASBRs? No. In my case, between the RRs. So how do I do this? On R3, router BGP 100 neighbor 10.7.7.7 remote AS 200 neighbor 10.7.7.7 update source loopback 10 That is correct. Each other's AS prefixes. Which ones though? I'm not redisputing all the prefixes, only the loopbacks at this point from the RRs, so that I can establish that neighbor relationship. So R3 and R7, the two RRs, can establish the neighbor relationship. And the other thing that is important over here is this: neighbor 10777 EBGP multi-hop. Why? Otherwise, EBGP requires direct connection between the neighbors, and then enable it for what? Address family VPN v4. And on our AR7, what would I do? $200. This is going to be 10333. This is remote AS 100. This is also 10333. 7.23. 3.27. Neighbor up. Let's take a look. Show IP, not show BGP, VPN v4, unicast. Oh. I got the routes from the other side. And on R7, I got the routes. From whom? 10.3. Who did this guy get the routes from? 10.7. Okay. Now on R1, show BGP, VPN v4, unicast all. I have all the routes from the other side. Good so far? And because I will still keep this over here, because I'm doing it from option A to B to C, I don't need to worry about this. But if I had not done that previous B, I would not have these. I still have that route target import to import. So don't forget that step here. I don't need to do it because I have already done that for option B. But if I had not done option B, I would still need to change my RT values. Not change it, but add the new import. Everybody good with this? Now take a look. I go to 9. Reachable. 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 So the same reachability is there from one side to the other. But what I want you guys to also think about is this: the path it takes. When I propagated the routes, this guy propagated the routes to him. What's the next hop? For all the routes. I did not do next hop self, which is a good thing, because when he sends a route to him, or to him, or to him, they get the route with the next hop of what? So for them, 10.9 is reachable via 10.3. And for this guy over here, 1011, for example, he would have received all these routes with the next hop of 10.7 via 10.7. And I can verify that in my routing table. If I go to R1, show IP route VRF cost 8, you will notice that in order to reach what? 10.11, my next hop is 10.7. Now let's take a look at the path, the data path it takes. R1, how do I reach 10.7? 10.7 was redistributed by him in OSPF. So he knows about 10.7 via this network, which is good. I'm not going to send the data traffic through the RR, but I'm still sending it to 10.7. So although R8 could have sent the route directly to 10.11, he's sending it like this. You guys understand that? You understand how over here in AS100, it took the direct path to R8 because to R4, because R4 is the one that received 10.7 from BGP, and he's the one that redistributed the route into what? This guy and this guy into OSPF. So if I go to R1, 10.7 would be reachable direct. So over here it says 10.11 is reachable via 10.7. And if I check my OSPF routing table, 10.7 is reachable via 100.4 direct. So coming back to the diagram again, what is the path? The data path is the blue highlighted line. VRF routing table on R8 for what? The route will not come into the VRF, Ernie. Because the packet, when it goes, it's going to go as a label packet, is destined for 10.11, right? This packet is meant for 10.11. So it's going to be a label packet. Label of 10.7, which is going to be a label packet all the way across to this guy. So he doesn't see the route. So in AS200, can I do a better job of doing this? Is that what you want as given? That you want it to take this one, right? Is that what you want to do? So that you avoid this, correct? So how do I do that? Why did I have to do the path through R7? The reason I had to do the path like this is because my next stop over here is what? 10.7. So it'll generate the label for 10.7 and send it across. There is an option in BGP. If you look at the routing table, the BGP VPN v4 table over here on R7, you will see that 10.11 is reachable via 10.5. 10.12 is reachable via 10.6. You guys agree? In the MPBGP table over here. When R7 sends a route across over here, it's eBGP. So generally eBGP, what does it do? It changes the next hop to itself. So he gets a route as 10.11 is reachable via 10.7. 10.12 is reachable via 10.7. Agreed? There's an option in eBGP which is called next hop unchanged. When R7 sends a route to R3, if you want, you can tell it not to change the next hop. Keep them as 10.5 and 10.6. So when R3 receives it, R3 would receive the route as what? 10.11 via 10.5, 10.12 via 10.6. That would allow the packet to be propagated which way? Because the next hop is 5, but this guy will go this way. If it needed to go to what? 6, it would go this way. So again, you are taking the RRs out of the data plane. Good? This command over here. But I'm not done yet. When I do next hop unchanged, does AS100 over here know about 10.5 and 10.6? What is the only loopback that I leaked out from 200 to 100? The next hop reachability of the RR. So if I do the next hop unchanged and you want it to work, you not only need to leak out the 10.7 to 10.3, which is to establish the control plane neighbor relationship, you need to leak out the P next hops as well. By leaking out the P next hops, you will do that direct path. Somebody asked me that question early on. I said, I'll show you 2 different ways of doing it in option C. I don't know who it was, but one of you guys did. You understand what I'm saying now? So if you want the efficient forwarding, that's how you would do it. Let's do that real quick over here. So if I wanted this to work, what I need to do in my leaking, when I leak out from where? From AS100, I'm going to leak out 3. 1 and 2, not just 3. So it has reachability to the other devices directly. And then on the other side, I would have received ACL2 with a permit of 10.5 and 10.6. This is just one way. Just put that. What's a drawback? A bigger portion of your inside network is exposed to the other AS. And I need to do the same thing on R8. I need 7. 5 and 6 over here, and I need 3, 2, and 1. Actually, I also need 8, but forget 8 for right now. We'll just focus on the other edges. All the PE routers. This one I done. This one I have to do. So once this is all said and done, if I go to R1, I don't see 7. I should also see 5 and 6. It is BGP, so where is this R4? Do mess up, show IP BGP. 1, 2, and 3, and 7. I'm getting it. So 8. Oh, why is this getting propagated over there? Oh yeah, this guy is also sending the route because I have a BGP relationship between R3 and what do you call it, R7. That's why I'm seeing it from two different locations. So over here, I would need to disable sending of IPv4 routes on R3. But how come R3 should not be sending it? One second, I did something wrong. R3, okay, this one is okay now. Why is it coming through BGP though? Oh, I know why. R4 has a BGP relationship. The whole thing is, I don't need to have a BGP with this guy. Because the ASBR will not have a BGP relationship with R3. So no neighbor 10.3.3.3. There you go, it'll solve the issue. That's, yeah. Yeah, this is better now. 10.5, 10.6, 10.7 over here. And R6, show IP route, OSPF, should have 1, 2, and 3. No, route name is, all that was okay. The problem was I was also sending the same route through BGP, which I stopped. Because of option B, I had set up a relationship between 3 and 4, and that was also propagating. So I took it off, now it's okay. Now R1 has this guy and this guy. What I can do to fix it, I'm still taking what path? Because the next hop unchanged is not there. I'll show you this before and after. How many hops do you guys see over here right now from R9 to 1011? Goes to 1, goes to 4, goes to 8, 8 to 7, 7 to 5 to 11. 6 hops. So my connection right now, 1 to 4, 4 to 8, 8 to 7, 7 to 5, 5 to 11. That's my path right now. What I want to accomplish is this. Right? Avoid this. How? That's what I want to show you guys over here. On R3, when I go into my address family VPN v6, sorry, VPN v4, I specify neighbor 10.3.3, 10.7.7.7, next hop unchanged. Don't change the next hop when you send it. What does that do? If I go to 7 now, you'll notice that 9 is coming from what? 10.1. 10 is coming from 10.2. Before, both of them were coming from 10.3. And vice versa. On R7, again, same thing. address family, VPN v4, neighbor 10.3.3.3, next hop unchanged. But this would require you to redistribute the PE router addresses as well. Now again, show IP, show BGP, VPN v4, unicast all. 11 is coming from 5, 12 is coming from 6, 14 is coming from 8. Now, if I go to router 9 and I do the same trace route, went to 1, to 4, to 8, directly to 5. So the one that it skipped is this guy. So this now it is taking the path that we discussed because of the next hop unchanged. So now it's taking this path. Understood? As given, this is what you wanted, right? But again, I showed you how to accomplish that. What's a pro of it? The pro is the best forwarding path that you have. You're avoiding the RRs on both sides. But the drawback is you need to leak out what? Information of the next hops to each other. Good, everybody? Questions? Trust between the ASs of the PE routers. Yes, you do need to have that. Let me put this for you guys. If you want the RR to be RR, if you want the RR not to be used in the data path, configure the next hop unchanged command or parameter for the EBGP route exchange. This would require you to leak the loopback addresses of the PE routers in addition to the RR address. And what was the command on R3 that I did? Router BGP 100 under the address family, assuming I've done all the other stuff. Neighbor 10.777, next hop unchanged. The concepts you guys are okay with? I won't be able to get to the XR or the other stuff, but I wanted to spend a little bit more time on these different topologies. What I will do is I will send you my lab for iOS XR. Actually, let me just do it right now so that I don't forget. Page is it? 292. It's the same topology that I have over here, 292 to 311. So print. Yes, Kraus. Let me see if I have it. I'll put it. Give me 1 second. Let me print this out. 292 to 311. If I have it, it'll be in this folder. MPLS VPN v4 I don't have over here. CCNPRS. See, this is the CCNPRS notes. That's the other class that I've done for you guys. I've seen it somewhere. It's not here. Guys, if I find it, I'll definitely upload it. I've seen it somewhere. I just can't see it right now where it's at. See if there's any other way. Oh, what do you know? I found it. Too much stuff, man. I just need to organize it a little better. I have it. It'll take some time. I need to, because it's in different folders. So it's got the video as well as the notes. Okay, I'll upload it. I'll put a different folder underneath it, and you can just copy it from there. So let me do this first, the stuff that I needed to do for this one. I've done all the changes. This one is done. So, okay, I'm pretty sure you might want the topology. So I'll stop this. Which one was this? Intra-AS. Okay. All right. So now, so this one I got. I need to get you the folder, this file. XR. Okay, guys, keep on checking now. See if you have it. Day 1, day 2, day 3 notes. These are the topologies. These two RAR files are your videos. I need to do the video for this one. I'll send it to you tomorrow. The XR file is over here. The MPLS VPN is over here. Now for the other thing that you wanted was the VPN's Bootcamp. Okay, where to go? Right here. Files. It was under videos, I think. Over here. Yep. So day one, these two files. These are the notes, and this is the diagram from day one. File upload. Day two. Whatever I have, I'm uploading. This is the video. Day three I got. Now let's go to day four. Okay. I don't know what this extra video is. I'll upload that as well. Yeah, this is a big one, so it's going to take some time, but it'll be uploaded. It's about a gig. All right, guys. So this is it. Hopefully it was helpful. Thank you. Yep, Bill. Thanks, guys. Thanks a lot. Probably around Feb. Feb of 2019, yeah. Thanks, guys. Let the people at RouterGods know about that annual package special that I'm running for you guys for the 2 months. This is my this is my website though. It won't have that 2 year. That is something that I've just told you. I haven't come up with the schedule for 2019 yet. I'll probably do it next week. So you'll see the class for next week. I do have a CCI security starting this Saturday. If you guys are interested, send me an email. The first class is free, so you can join in, take a look at the first class for free. All right, guys, you take care. You guys have a Merry Christmas, Happy New Year, Happy Holidays. Take care, guys. Good night.